Hi learners, I'm Dr. Mohammed Abdul Wajeed, Professor and Head, Computer Science and Engineering Department, Lord's Institute of Engineering and Technology. In this video, we will be trying to learn the operations on single linked list. The operations are insertion, search, traversal. We will be trying to learn about these operations. So what are the operations which can be performed in case of this single linked list? Let's try to just look at this. So to solve this particular problem, so here more of is a coding part itself. So thereby we will now also try to do some sort of a coding, and we will also try to see what are the operations which can be performed in this. So to go with this coding part, here I am trying to take up a uh, online compiler. I am relying on an online compiler, so let me just try to check it out whether everything is running fine or not. So to that I am trying to run this program, so thereby the compiler is working all fine. Okay, so to solve this particular problems, let us try to do this programming in modular phase. Okay, so what is this modular phase? Let me try to just write the code rather than just explaining. So let us do some hands-on. So wherein I am trying to say that we will be in need to do certain operations. So these operations, when we are trying to perform these operations, let us have a menu driven program, and let us write some separate functions for each and everything. So let me try to write the function for menu. So as you already know that this is what is the definition, this is the declaration. Now I'm trying to write the definition of this function. Printf, 1 for insert, 2 for search, 3 for delete, 4 for traverse, 5 for exit. Okay, so here I have made now two functions. So this is one module which I am trying to just say. The one module is menu, and the other module is of course the main program. Main program has to be the is a must, but because our execution always begins with only the main program. So thereby I have written this now the menu function. So similarly I have to write about inserting, I have to also write about traversal, I have to also write about the deletion, and so on, all the operations. So now let us just try to first of all create the definition for a node. So as you all already have seen this earlier in the slides, so thereby I am trying to create a node, so in which I am trying to store the data which is of the type integer, and it's a recursive definition, so structure node, and it is of the type pointer. So in short, instead of writing pointer completely, I'm trying to write ptr. So thereby I want to create a root node which will try to store the information about the first node address. So node star root. So thereby initially it is going to be null. So if you look at here, I have done this part. So if you see this highlighted particular line of code, so and with the animation part, so at the beginning root is containing some garbage value. Okay, so when I execute this, root will be containing some garbage value actually. But now instead of containing it as a garbage value, I am initializing it to null. So thereby, right now the root is containing the null value. Okay, so now what I do is I'll write a while loop. So I'll try to explain why am I writing this while loop and etc. Or else let me call this menu function first of all, menu. So what is the result we have got? That I am trying to store it in a variable called as response. So res is a variable of the type integer. So let me try to declare that integer also here, response. So what did the user enter? So thereby he might be entering in res some values, either it can be 1 or 2 or 3 depending upon what is there, we have written it in the menu. So case 1. So case 1, what is that we have tried to say is it is about insert. So let us now say he is going to perform insert root. So before I go to this, let me also try to tell you one more small point. So as you could just see here, it can be done with a head node, without a dummy head node. Okay, please make a small correction, with the dummy head node, without dummy head node. So thereby the word dummy is missing here. So please add up that particular part, with dummy head node, without dummy head node. So why this is very important? So we will try to first of all solve this problem by using dummy head node. So why this is required? So why? Because now if you try to take up a single linked list, so maybe I am having a variable called as root, which is containing the address. Let us just suppose the address of this is 1200. So the data here I am trying to store is say 5, and there is a next node. And now let us just suppose here I am trying to create a new node at 1500. So the data which I am trying to store here, it is 30, and the next node which I am trying to store is say 1800. At 1800 I am trying to store somewhere about say 20, and say for instance right now I'm not having any other node. So if I am having it like this, after some time maybe I want to insert before 5. Before 5 if I have to insert, thereby I have to create something. Maybe it has created an address called 2500, and this 1200 I have to store it here, and this 2500 has to be stored here, and whatever be the element here, maybe 3. So here what is it happening is root is getting changed. So similarly now after some time I may be interested in trying to delete the first node. If I have to delete the first node, then the successor node of the first existing node is 1200. So once again the root value should be changed. So thereby when I am trying to write the programming, I should do the implementation in such a manner that root value should be changed in some cases, and in some cases it should not be changed. When we are trying to add at the beginning of a single linked list, root value has to be changed, and if I am not adding at the beginning, root value need not be changed. So that becomes little difficult at the implementation stage. It's not very difficult, but to start with. So thereby what I suggest you is you create a dummy head node. So thereby maybe it is created at 1000, and your actual data begins from here. So your actual data begins from this place. So thereby maybe this is created at somewhere about 1500. Let us suppose this is created at 1800. Let us suppose this is created at 1600. So maybe I'm going to store 1600 here, 1800 here, and no doubt here also I'll store here 1500. And what is actually, and this is null here, and what is actually the data, maybe say something like 15, then 20, and say something like 10. So the question of now you deleting, I mean, and here some sentinel value, let us put some sentinel value. Sentinel value is a value which is beyond the some particular in an application, that is not a valid value. So now let us just try to take into consideration about if 15, 20, 10, these are the roll numbers, maybe I'll put -1. There is no student with a roll number like -1, or else it can be something like 500. So wherein we are assuming that no student will have a roll number like 500. So it can be any such value. So thereby the question right now is deleting this node will never be arising for you. So similarly, even if you are trying to insert before 15, you will be inserting it, though it looks like something like at the beginning of a node, but still since the dummy head node is there, so this is your dummy head node. So thereby root will no doubt be containing still right now is 1000. But we have to be little careful while traversal. So you should not print the value whatever is there in the dummy head node. So you should skip the first node and then go from the next node like this. So that is the advantage which we will be getting across. So thereby we are now trying to create it with a dummy head node. So since it is with a dummy head node, I'll try to create that dummy head node at the main program itself. So thereby root equals to structure node star malloc size of structure node, and wherever we are using this malloc, either we have to use alloc.h or standard library. So I am expecting that the student is already aware of how does this memory allocation is being done in case of dynamic array or any such particular need of such type. So thereby I am not explaining this what is this malloc and all that part. So I am expecting the student is already aware of it, or else maybe in the earlier classes it is already there. So thereby you can just look into that. So thereby here to store the data I am going to use -1, and right now there is no next pointer to it, so thereby I am storing here null. So these are the three lines which will be trying to create a dummy head node. So the very first line, that is line number 14, it is trying to allocate the memory. So line number 14 is trying to create the node, memory is being allocated, and we are trying to store using the line number 15, we are trying to store some dummy value, sentinel value, which I have already mentioned, which is -1 here. And since at the moment there is no successor for that particular node, so thereby we are trying to store null in that. So this is how a dummy head node is being created here in this case. Okay, so now let us try to speak about this insert. So how do we perform this insert? So here what do we do is, so there is no return value since the root value is not going to be changed, so thereby the return value is going to be void. So insert, let me call that function name as insert, so to which I am going to pass the structure node pointer some r value, I mean some variable, you can use it here. So next to this is structure node star t. So let me write first, then I'll try to explain. Structure node star malloc size of t. So let me also create one simple variable of the type integer to store this. So now I am trying to say printf, enter the element. So let me write first, then I shall explain. Data equals to yearly, and now here I have to write some while loop. Okay, so let me try to explain what is it I have written here first of all. So there is a function called as insert. What is it going to do is, it's going to take uh, let me make some correction here, element spelling is missing. Okay, so there is a function called as insert. What is the purpose of this is, it is going to insert a node at the end of the existing single linked list. What it will take, it will take the root node's address, so thereby the input to that is root node's address. And what is, so this is how it is receiving it here. And what is the output? There is no output, I mean there is no return, I mean to say is. So that is the definition. And now next to this I am trying to create a variable of the type structure node which will try to store some temporary values, whatever. Next I am trying to take a ordinary variable of the type integer, and here actually I am trying to create the memory for storing a node. Okay, and what is the value which you want to store in the node? I am trying to access that, and so I am reading that through using the scanf, and whatever be the value you have read in the scanf, that I am trying to store it in the node. And since there is no successor for this, so thereby I am trying to store null. So if you look at here, so if you just try to see this comparison, So here it will be something like this. You have created a node. So now let us just suppose you are having, so maybe this is the dummy head node which is 1000, and now let us just suppose this is at 1200, this is at 1500. So the data here I have stored as -1, and this is 1200, and this is 1500, and this is null. So we have created a new node. So this is maybe the new node. Okay, so just now I have written the insert function. So thereby what did I do? I have created here line number 27. What it is doing? It is creating a node. So thereby T is going to contain the address. So let us suppose the address of this is 1800. So this is node is created. So I am trying to read now what is the value you want to store. So I am reading that by using printf statement, enter the element in line number 28, and line number 29 you are reading yearly. So now let us just suppose you want to store 52 in that. So thereby 52 is going to be stored eventually here by using this in line number 30. And in line number 31 I am trying to store here null. But if you look at, this is our single linked list and this is not connected. So you have to connect it. So how do we connect it is, here in case of this variable R, I am trying to store what is the address of the root node. So R is containing how much? 1000. So thereby I should come using this 1000, I should come to the last node. Okay, and then I should get this address somewhere stored 1500. Using that 1500 I have to change this and it should be containing this 1800. So let's try to see how we do that. So thereby here I am writing the while loop, while r is rptr is not equal to null. What is that I am going to do is only one single line we are supposed to write here, but anyway, so r equals to rptr. And after that I'm going to say is rptr equals to t. Let me just try to explain how it is going to work. So here first of all I'm saying rptr. What is this r is containing? R is containing right now 1000. 1000's ptr. How much is 1000's ptr? It is 1200. So actually speaking truly it does not matter, but here r is right now referring to a dummy head node. So it should not be referring to dummy head node, means maybe you can try to say r equals to rptr. So by doing this in line number 32, what happens? R will right now be containing is 1200. Okay, but whether we write or not, it does not make much of a difference. So thereby, why? Because whether it is we are not printing. So since we are not printing, somehow this r equals to rptr, I am doing it in the while loop. So thereby, it doesn't make much of a difference. Okay, so thereby right now r is containing the same 1000. So rptr, how much r containing is 1000. 1000's pointer, how much is 1000's pointer? Which is 1200. 1200 is not equal to null. It is satisfied. Since it is satisfied, it has to execute there in the while loop. What is there in the while loop? We are having an assignment statement. rptr. How much is r value? 1000. 1000's ptr is how much? 1200. Where it has to be stored? It has to be stored in r itself. So thereby r right now contains is 1200. So next again what happens? While loop will again start. R right now is containing how much? 1200. 1200's ptr is how much? It is containing right now is 1500. 1500 is not equal to null. In the while loop is satisfied. So thereby again while loop has to be executed. In the while loop what it has to do? rptr value has to be stored in r. So how much is r value right now is 1200. 1200's ptr is how much? 1500. 1500 has to be stored back again in r. Okay, and next like this, once again rptr. What is r right now containing is 1500. 1500's ptr is how much? Null. Null is not equal to null, is not satisfied. So thereby this while loop this time does not execute. So thereby right now we are going to have this line number 37. In the line number 37, what do I have? Again as an assignment statement, t value. this T value which is 1800, where we are trying to store that in RPTR. R's PTR. R is containing how much? 1500. 1500's PTR is where? This is the place. So what I am going to store in this? 1800. So this will be removed and 1800 gets stored here. So thereby, let me draw it once again properly here. So it looks right now like this. Some data was being already stored here. So this is what is the linked list which was pre-existing to us. So next to this, what you have to just say, and just we have to say return back. That's it. So what is this insert doing? Always inserting at the end of the single linked list. This is always adding at the end of the single linked list. Thank you viewers for watching this video. For more videos, please subscribe. Thank you.